In this SATSOFT how-to video, we show how to lay out and compute 4-color antenna beams according to a regular grid of polygons. The starting point is a polygon layout as seen here, which we have set up in another video that we link to. In this concrete example, we consider a satellite at 120 degrees west, and we want to generate 1 degree 4-color beams over the contiguous US CONUS in Ka band around 19.7 GHz. The project starts where the other video ended. In that video, we set up the regular grids of polygons that we see with the 4 colors over CONUS here. The first step is to add these 4 polygon objects as child objects of the respective antennas. This is done by dragging and dropping the polygon objects onto the antenna objects, which adds them as child objects to the antenna. After this is done, we do not need the polygon objects as child objects of the satellite and therefore delete them. Then the composite view is blank because we've not yet laid out and computed the antenna beams. We now proceed to setting up the antenna model. We start with antenna green, double-click on it in the Project Explorer to open. The subpolygons from polygon green are shown on the map. We'll now be changing the antenna model to the multi-feed reflector antenna model, a high-level antenna model for a parabolic reflector illuminated by an array of feed horns that is available with the payload antenna planner add-on to SATSOFT. And to change to this antenna model, go to Antenna, Model, and select Multi-Feed Reflector. Next, we go to Antenna, Model Properties to set the details of the reflector antenna and the feeds. We first change the aperture size to 0.95 meter, and then we change the beam spacing to 2 degrees, as we would like to space the 1 degree beams by 2 degrees. We change the feed model and change the frequency to 19.7 GHz. Also, the polarization is changed to right-hand CP. And finally, we increase the focal length to 1 meter. With these changes made, we see that the peak directivity is estimated to 44.94 dBi and the aperture efficiency to be just over 81%. In the illustration below, the reflector is seen in a rear view, and by clicking on the arrow below the illustration, we switch to a side view, which gives us an impression of the reflector optics, and we can then click OK to close the dialog when we're happy. We're now ready to lay out beamlets for the reflector antenna, and to this end we go to Antenna, click on Beamlet and Station Grid. This opens up an associated dialog. And in that dialog we'll be laying out beamlets according to the polygon green polygon. We change expand coverage to 0.1 beam width to ensure that we only get 1 beamlet per subpolygon. Then we click on Generate and then on OK. We now have 1 beamlet per hexagonal subpolygon as indicated by the circular markers on top of the subpolygons. And we're ready to compute the associated component beams. This is done by clicking on Compute Component Beams in the top menu. Preset contours of the computed component beams are displayed on the map. To modify the displayed pattern contours, we right-click on the map and select Component Contours, which opens this dialog. We delete the -1, -2 dB contours as we just want to see the -3 dB below the peak contour. We change the contour and fill colors to dark green. Likewise, we increase the font size to 12 and change contour label to none and click OK. On the map, we now see the green beams with peak directivities for each beam also displayed. Next, we similarly want to lay out beamlets as well as compute and visualize component beams for the 3 other colors, with the difference that these beams will be laid out and computed according to different polygons. We have already set these antennae up as multi-feed reflector antennas with model properties as set for antenna green, so we can proceed directly to lay out beamlets and compute components beams, starting with antenna red. In the component contour dialog, we could type in the same settings as for antenna green, but we have prepared the needed settings in a file, which we can load via Load from File. This sets the setting, including the red contours and fill colors. The red beams are shown on the map on top of the red subpolygons. The exact same procedure has to be done for antenna blue and antenna yellow. In this project we've already set it up, and therefore we return to the composite view where we see beams from all 4 antennas. As a note, the bore side for each of the antennas has here been set automatically, which places it in the center of the first subpolygon. In this case is the bottom left subpolygon. In a practical situation, it may be of interest to place it elsewhere, which can be done, for example, by setting its coordinates manually. We also note that it's possible to export the antenna setups for more detailed analysis and optimization in GRASP and PAWS. Thank you for watching this SATSOFT how-to video.